Hi, my name's Suman and I'm going to be teaching you about alkanes. So I'll be discussing what hydrocarbons and alkanes are. I'll be discussing the categories and differences of hydrocarbons. I'll also be discussing the characteristics of both hydrocarbons and alkanes and the IUPAC system for drawing and naming different alkanes. Note during the presentation that if points are highlighted, you can stop the presentation if you want, just to take notes to remember for later. Okay, so to understand what alkanes are, we first have to understand what hydrocarbons are. So, hydrocarbons are just organic compounds that only consist of carbon and hydrogen atoms. And alkanes are just a type of hydrocarbon. So, alkanes are hydrocarbons that consist of only single covalent bonds. So we can also use some terms to define our knowledge of alkanes or describe our alkanes. So saturated and unsaturated. Saturated hydrocarbons are just hydrocarbons that consist of only single covalent bonds, and unsaturated hydrocarbons are hydrocarbons that they can consist of double bonds or triple bonds or maybe even more. And chained versus cyclic. So cyclic hydrocarbons are hydrocarbons where their carbon atoms form to make some sort of shape. So they all connect to each other. And usually they make shapes like squares or triangles or pentagons. And chained hydrocarbons are hydrocarbons where their carbon atoms connect to just form one straight continuous chain, and they don't form any single shape, it's just one straight line. So there's one more term that we can use to describe our alkanes. So aliphatic and aromatic. Aliphatic hydrocarbons are hydrocarbons where their carbon atoms just form chains and they don't form any ring or they don't connect to each other in a certain way. So they're pretty much just any hydrocarbon without a benzene ring, which is what it's called. And aromatic hydrocarbons are hydrocarbons where their carbon atoms all form to make a sort of circle shape, which is called a benzene ring. There are three different categories of hydrocarbons. The first category are alkanes, which we were learning about in my presentation. The second category are alkenes, and the third category are alkynes. So the first category, alkanes. So we know that they are hydrocarbons and they are joined by only single covalent bonds, like in this diagram right here. These sticks represent the single covalent bonds, and you can see that there are no double bonds or triple bonds. And alkenes are hydrocarbons that are joined by at least one double bond. So like this one right here, this double bond makes it an alkene. And alkynes are hydrocarbons that are joined by at least one triple bond. So if there was another stick right here, it'd make it an alkyne. We can use the terms we just learned before to describe these different hydrocarbons. So for the alkane, like this model right here, it would be saturated because it only contains single covalent bonds, no double bonds or triple bonds. And alkenes would be unsaturated because it contains a double bond. Now on to the IUPAC system for naming and drawing alkanes. So there are four basic parts to naming and drawing alkanes. The first part is the root, and the root is just the longest chain of carbon atoms in the alkane. So for example, in this model there are 1, 2, 3, 4, 5, which is the longest carbon atom chain in the alkane, which is the root. The prefix just gives us the position and names of any branches that are coming off of the alkane. These should also be in alphabetical order. The suffix just indicates the series of which the molecule is a part of. And the suffix for all alkanes is ane, so ane. Side groups are also just branches that are coming off alkanes, which makes it much easier to remember. So these two would be considered side groups for this alkane. So before we start naming and drawing our alkanes, we have to understand this chart right here. This chart is very important for doing this. So as you look on the left, it says number of carbon atoms, and it says all of the numbers, and then the root name. So if you have, for example, there's 1, 2, 3, 4, 5 carbon atoms in this root, so the root name would correlate to pent, as you can see on the chart. And for side groups, if there's just one carbon atom, like you see right here, it would be methyl. But if there were 2 carbon atoms in the side group, it would be ethyl, and so on. So now I'll be teaching you how to name alkanes using the IUPAC system with the terms that we just learned the slide before. So you can pause the video if you want to take the notes on how to name these alkanes, but I'll be also playing a example video right now. Okay, so now we will be learning how to name alkanes. There are 4 steps to naming alkanes. First step is to identify the root of the alkane. The second step is to identify the suffix of the alkane. The third step is to identify the prefix of the alkane. And the fourth step is to just put it all together, or name the alkane. So we'll be doing this example right here. So number 1, find the root. So we know that the root is just the longest continuous chain of carbon atoms in the alkane. And we see that there are 1, 2, 3, 4, 5, and 6 carbon atoms. So 6 carbon atoms in the chain. And if we look at our chart, 6 would be hex for the root name. So our root name would be hex. And number 2, suffix. So we know that this compound is an alkane because it only contains hydrogen atoms and carbon atoms, and they are all connected by single covalent bonds. So alkanes have all the same suffix, and the suffix is -ane. So that is our suffix. Prefix, the hardest step out of all of them. We see that there are 2 side groups with just 1 carbon atom, and then right here there's another side group, but it has 2 carbon atoms. So side groups with just 1 carbon atom, as we see on our chart, they're called methyl. They're part of the methyl group, and there are 2 of them. When there are 2 methyl groups on the same carbon atom, we put a di in front of it to let the person know that there are 2. So we would put dimethyl. So now we just have to state the carbon atom number it is on. So when it is on the 3rd carbon atom number, so then we just write 3 dimethyl. We'd write 3 because they're both on the same 3rd carbon atom. So that would be the prefix for this one right here. And now this one, it's just 1 on number 4, but there are 2 carbon atoms. 2 carbon atoms would be part of the ethyl side group, as we can also see on the chart. So, and we don't need to put a di because it's just 1. So it would just be ethyl. But we also have to put the carbon atom number it is on. So it is on number 4. So we would just put 4-ethyl. So that is our prefix. So if we complete our prefix, it would be, since we have to put it in alphabetical order, E comes before M, so it would be 4-ethyl dash 3,3-methyl. Dimethyl, sorry. So 4-ethyl dash 3,3-dimethyl. Okay, now number 4, we just put it all together. So we would write our prefix as it is. And then the last step, we have to combine number 1 and number 2. So the root and the suffix, we just add them together. So we know that the root is hex and the suffix is -ane. So then hex plus -ane, hexane. So we just add hexane at the bottom. So at the end of our alkane name. So the full name of our alkane is 4-ethyl 3,3-dimethyl hexane. So this would be the root, this would be the suffix, and the rest would all just be the prefix. And that is how to name alkanes. Drawing alkanes using the IUPAC system. You can also pause the video right now just to take notes, but I will also be playing an example video of how to do this right now. Hi, so I am back again, teaching you how to draw alkanes now instead of naming them. So there are 5 important steps to drawing alkanes. The first 3 are the same as just naming alkanes. You just identify the root. Number 2 is the suffix. Number 3 is the prefix. But number 4 and 5 are new. So number 4, we have to complete the structural formula. And number 5, we have to complete the line structural formula. So number 1, we have to find the root. So if we know how to name alkanes, we should know how to find the root in the name. So it's right here. Pent would be the root. So pent is the root. And if we look on our chart, pent would mean 5 carbon atoms in the chain. So there are 5 carbon atoms. And we can just draw that right now. So I'll draw it down here. 1, 2, 3, 4, and 5. Just add single covalent bonds. Number 2, identify the suffix. So the suffix is at the end of the name. Suffix is ane. That tells us that this compound is an alkane. So we know that alkanes are just connected by single covalent bonds. So now we know that. And now number 3, the prefix. So there's 1 ethyl and 1 methyl, and they're both on carbon atom number 3. So as we know, ethyl groups contain 2 carbon atoms, and methyl groups only contain 1. And they are both on the 3rd carbon atom. And we can draw these on either side, it doesn't really matter. So I'm going to draw the methyl on top and the ethyl on the bottom. So methyl is just 1 carbon atom, so we just write 1 right there. And then ethyl would be 2 carbon atoms, so I'm just going to draw 2 like that. We can also draw them on the side, but it doesn't really matter. Now, number 4, the structural formula. So right now, this is just the base of our alkane. And to complete the structural formula, we have to draw the hydrogen atoms beside the carbon atoms. And the trick for this is we have to make sure every carbon atom has 4 bonds. Doesn't matter which bond, just 4 bonds. So, for example, this one. It already has 1 bond here, so we would have to add 3 hydrogen atoms to make 4 bonds. And now for this one, it has 1 bond here, 1 bond here. So that's 2, and we just have to add 2 to make it 4 bonds. This central carbon atom already has 4, so we don't have to do anything with that. And we just continue the process with the rest of the carbon atoms. Okay, so now we completed the structural formula. Now with the line structural formula. So number 5. So to draw the line structural formula, for the carbon chain, it's just a zigzag. So pretend I have this, right? Each end of the zigzag line represents 1 carbon atom. And we have 1, 2, 3, 4, 5. So there's 1, 2, 3, 4, 5 in this one actually. So we can use this one. So that represents 5. So that represents the chain, our carbon chain. And then for this one right here, we do the same, just like that. just a little zigzag. So there's 1 point here, 1 point here. That represents 2 carbon atoms, which we have. And for this 1 carbon atom, all we have to do is just draw 1 straight line to represent 1 point, which is 1 carbon atom. And that is how to draw alkanes. There are also some characteristics of alkanes that we need to know. We need to know that alkanes are nonpolar. They are not soluble in water, but they are soluble in other nonpolar solvents, since water is polar. And the state of matter and boiling point depend on the size of the alkane, more specifically just the number of carbon atoms in the alkane. So when there aren't many carbon atoms, around 1 to 4, the alkane will be a gas, and a bit above 5 to 16, the alkane will be a liquid. And then a bit above that, it would be a heavy liquid, sort of like a semi-solid. And then even more above that, it would just be a solid residue. So this is now the end of my presentation, but there are some review questions and a quiz that I made that you can work on just to test your knowledge about this alkane subject. So in the textbook, page 19, 1 to 11 and page 21, 12 to 11 are some questions that you can use just to practice your knowledge on this. And there's a quiz with the link in the slideshow that you can use just to test your knowledge and see how many you get right. So thank you for watching and have a good day.